Good afternoon, my name is Ray Elise and welcome to webinar 2. This webinar is to take you through the fundamentals and we've called it SketchUp in a nutshell. But before we start, let me give you a little introduction about what we mean by sustainability.
What is real sustainability? It is understanding the full and lasting impact of our design choices and reducing the carbon footprint over the building's entire lifetime, from cradle to grave. Two phrases you will often hear are embodied carbon and operational carbon. Embodied carbon is the amount of carbon emitted during the creation of the building and its materials. Operational carbon is the amount of carbon emitted during the life of the building and maintaining those materials. The building industry is focused on decarbonisation. The current method for measuring the CO2 impact of each material is through a life cycle assessment using Environmental Product Declarations, or EPDs for short. Unfortunately, EPDs assume the study period for a building's life is only 60 years, which is just 1% of the age of the oldest fired bricks in the world, made 6,000 years ago and are still here today. This is important because durable products with extensive longevity such as clay brick prolong the expected life of a building, resulting in a lower carbon footprint for every year of use. Brick can then go on to be reused and recycled to live a second and sometimes even third life or more, benefiting multiple generations. We often hear the brick industry say clay products last over 200 years. This is more than 3 times longer than EPDs measure the carbon impact, therefore designers do not receive life cycle assessments reflective of the true lifespan of their building. Brick is non-toxic and requires little to no maintenance. It's non-combustible and improves the thermal and acoustic building values, equating to 0 operational carbon. Other building materials need much greater levels of maintenance, often reliant upon chemical processes which lead to a considerably higher operational carbon footprint. Many of these non-clay materials will often require complete replacement several times over a building's 200-year lifespan, multiplying both the embodied and operational carbon footprints several times over. In reality, when measuring your building's design over its true lifespan, clay brick is one of the least carbon-intensive building materials you can use. At Michelmersh, we know exactly what goes into creating our products and meticulously calculate the embodied carbon figures, providing completely transparent data from extraction to drying, firing and delivery. To be truly sustainable, we believe in designing buildings that are both adaptable and multi-generational, so that the environment and our children's children will benefit from the choices we make today. Think longer. Designed for 200 years, not 20.
So I hope you liked that short introduction into sustainability. I posted a series of web links in order to help you guide you through the challenge itself. So I will leave this for you to actually divulge and read at your own time. Obviously, a lot of the events we're doing are through Eventbrite, and that there are also links to YouTube, which will hopefully give you the relevant skills and understanding as to what the challenge is about. So what we plan to do altogether, that we have in this first part a series of 5 webinars. The first webinar we delivered on the 8th of December, which talks about the site appraisal and give you some exercises on how you can actually formulate ideas. This webinar is about SketchUp in a nutshell, and then what's going to happen is that over the next 3 webinars, which we have on the 26th and the 2nd of February, is that we're going to actually go into SketchUp in a little bit more depth. And then finally what happens is in webinar 5, we'll look at how we can actually import our model into the layout book itself. In the second phase, we have a series of webinars which takes through site analysis and planning. So this is more actually akin for students who are in higher education, who actually want to get involved regarding the master planning of the site itself. And so what we have within those webinars are are tutorials on the use of Saphira to carry out sun and light analysis, and we'll also look at how we're going to create 3D animations, and again how we can actually bring this into your layout book to create your final presentation. Over the period of the challenge, we have scheduled a series of workshops. Each workshop is scheduled for 3 hours, with the first one on the 16th of February and the second one on the 9th of March. The third workshop on the 6th of April, the venue is to be defined, and I will inform you of that later in the time. So today's webinar agenda. So I want to give a very brief overview. We're going to talk a little bit about the criteria that we need to include for designing an inclusive home. So we'll look at the Disability and Equalities Act, and then we're going to look at how we can create a template file. Even though I will actually will provide you with one. I think it's interesting for you to understand how you can actually formulate your template and select which template you're going to use from SketchUp, and then we're going to go to basic modeling techniques. To conclude this webinar, there will be a short Q&A period. And I will be uploading the SketchUp file SK1LC-01, which is a template file, and then we've also provided you a series of additional information, which have YouTube links, which will enable you to take you through the process of actually self-learning, in addition to what we're showing you. As was highlighted to you in our first webinar, is that the site for the design challenge is Silo D, of which it is actually broken down into 4 areas, as highlighted on the screen here. And it's given you the option of how you can actually engage with the site to develop your ideas. So, in order to actually make our homes inclusive, we need to consider what was required by the Disability and Equalities Act in 2010. This technically was actually brought in for all housing from 2010 to ensure that homes that are built do clearly provide us with inclusive living. The reality, however, is actually far from the truth. I would probably consider very few houses that are built these days do actually consider most of these points. I've highlighted 8 points for you, which you need to consider when creating a sustainable house. One, the factor is that we need to have a house which has got a level entrance point, which has a provision of a 1500 by 1800 clear area, free of any obstructions. We need to consider minimum door width of 860 millimeters. This is for us to actually allow for wheelchair access into the property itself. We also need to consider actually using contrasting colours around the openings itself. This is very much for people who have actually got impaired vision, who can't always fully see where a door starts and a wall finishes. Other things that we need to consider is provision for 1500mm turning spaces within all the rooms for wheelchair users. We need to consider heights of switches to be 600mm above floor level, and a maximum height of light switches of 1200mm. If we're going to consider having steps within the house itself, which would be suitable for what we classify as ambient disabled people. Therefore, what happens is we're confined to have a maximum stair rise of 170mm and a minimum going of 250, with a landing of 1100 by 900mm on every 8th stair. And finally, we need to consider that if we're going to have ramps within the building, is that they again need to have a minimum width of 1100 and have a maximum gradient of 1 in 12. The Disability Act itself actually defines who are disabled people, and who who has an impairment that limits their ability to walk. People who are dependent upon a wheelchair for mobility. People who have impaired sight, and people who have impaired hearing. So in order to actually create a sustainable home, something which is inclusive, we need to consider all these factors when we're actually are using the space itself, which hopefully I will try to allude to you as to how this would actually lay out. So if we are considering creating a home for a single person, what's the minimum space that we require? Well, first of all, is that we probably can get this down to around about 60 square meters. So the factor is that we need to consider that within there's going to be a bedroom, which is going to have a minimum space of 3 meters by 3.5 meters, and a bathroom of 2.4 meters by 2 meters. From a sustainability point of view, regarding keeping heat in, we need to consider having a draft lobby so that when the door opens, all the cold air doesn't come into the building and hot air doesn't escape. So we need to think about how the units will link with one another and how it actually will create a sustainable home for the future. If we look at what the requirements require for a bathroom, as I say, the space is 2,000 by 2,400. We need to make sure that the door has an 860 clearance. We need to make sure that within the bathroom itself there's a 1,500 turning space for a wheelchair to rotate clearly within that. So therefore, everything's got to be clear of the area itself. We could consider either putting a shower in there, or we can consider including putting a bath within the room itself. But we have a minimum space for the bathroom. So what happens is, if you consider standard bath, 1,700 by 700, but we need to include a 450 millimeter zone at the end of the bath. So if somebody's in a wheelchair, they can sit on that, then rotate their legs in order to get into the bath itself. If we look how this formulates within the module itself, we consider having switches between 600 and a meter above ground level. We have the bedroom, which is, again, we need to make sure that we've got circulation space around the bed of 1,200 millimeters and 1,000, with a 1,500 clearance again at the foot of the bed. And so the factor is, we need to consider we have 1,100 of unobstructed openings. Any windows that we need to include within the building itself need to have a minimum height of 800 millimeters above floor level. And again, likewise regarding any internal doors, so that again this 860 millimeter, that is the clearance point of the door itself, not the door open itself. So the door itself potentially is going to be much bigger than that, probably more like 900 millimeters, possibly 925 millimeters wide. And so consequently what happens is, we need to think about the approach to the building itself. We need to make sure that the approach to the building itself, again, is clear. We need to make sure that the approach to the building is actually level. So if you are in a wheelchair, you can easily access the building itself. And so consequently, it's giving you full accessibility throughout. So in other words, to try and minimize any steps within the building itself. Obviously, the factors where we start talking about two-story buildings is that we need to consider actually how we would actually bring a staircase within the building, and possibly consider actually putting a lift into the building itself as well. But we'll talk about that in more detail when we come to designing a house for in the next webinar. So here is the formulated drawing that actually shows how the sustainable house can actually be created for for a single person. So we can see that we have the bathroom, we have the bedrooms, we have our draft lobby, we have a kitchen area, we have a clearance zone, and then we have our living zone. So let's start looking at SketchUp first of all. First of all, let's just go through the principles as to what SketchUp will provide for us. There are a series of shortcuts that we have within SketchUp. So, for example, the paint bucket, the shortcut is B. We have the line keys. We have a rectangular shortcut. We have circles. We have a keyboard shortcut for movement, which is M. We have a shortcut for scaling, and so hopefully what happens is this this overview will actually give you the ideas of how you can actually use shortcuts in order for you to actually work a lot more clearly. Also, it gives you an indication as to how the toolbars are used. So when we're setting up SketchUp, when we first open it, we're actually given this plethora of templates. So what we're going to use for our webinars is that we're going to use the plan view in millimeter template. This we feel is the best one for actually working for. It is clear. It's created with a good working environment. So first of all, what we need to do, we need to open SketchUp, and we need to create a new model, and then from that we need to actually select a plan view in millimeter. So when you open up SketchUp, within the template format that we've created, we've already set up how the various templates will actually be set out for you. So first of all, we need to think about that how we will actually set this up. So for example, by going to the edit tool itself, it actually enables to bring onto line things such as view sets, 3D. But predominantly what happens is when you look at it, we've got because we're looking in top view, is that what SketchUp provides us is the axes. So the y-axis, which is vertical, which is shown in green, and the red axis is actually showing in red. By clicking on O, we can actually go into our 3D mode, and now clearly what we can actually see the red and green axes. But now what happens is that we have the 3D, which is the blue axis, which in other words it's the Z. It is the Z coordinates. We can simply coordinate by going through. By navigating the file itself, and you can see we have our 3D house, we have a top view, front view, and side views. So by simply clicking onto those views itself, will actually bring us through the various process itself. So within the view sets that we have, you can quite clearly see how the axes are set up. We can see how the perimeters are set up. And so consequently, what we need to think about is what toolbars are we going to use. So when we're creating a template file, it enables us to actually select which toolbars we're going to use. So by clicking to view, it brings us into the toolbar tab. By clicking on the toolbar tab itself, it actually opens it up. And so by clicking on the various boxes, so for this template, we have the large tool set, we have measure, we have sandbox, section, Saphira, shadows, standards, styles, keys, tags, Trimble Connect, and the views. Now what happens is within SketchUp is that we have a thing called tags. Basically what tags are the layers. What layers enable us to do? They enable us to actually interrogate our model, close layers off, so that what happens is that we can create a series of views, and by having them aligned to a particular tag, we can shut them off, we can open them up, we can combine it. So it enables us to actually work a lot more efficiently and clearly. And so consequently what happens is, in order to actually to create a tag, we simply go onto the plus symbol, we click on the plus, it brings up the name, we name it, and what it actually adds it to our layer of tags. And so consequently, when we're actually working within the program, is that you can see that what we have the tags itself. We can click on the bottom itself, and therefore we can go from the untag to the base unit, component 1, component 2, component 3. So to start off with, we're going to start off by just having 4 simple layers. And therefore, when we're moving forward to add new tags, we simply go to the drop down box, and we actually click on the symbol and to actually add new tags. One of the issues that we need to be very much aware of is that when we're actually viewing the model itself, we can actually view it in 2 formats. We can view it in parallel projection, or we can view it into perspective mode. So to be more efficient, what happens is that we need to actually be very much mindful as to how we are viewing it. Perspective modes are great for actually when we come to do our final renders, because it gives us our particular view. So we can actually set the height of the camera, but predominantly when we're working and we're actually developing the model itself, it's always best to actually work in parallel projection. So by going into camera and selecting in parallel projection, we can actually change it to the default itself. So when we've completed setting up the template file, we can go on and click and save as a template file. We can actually type it in, and let's call the template file SK21-01 template. And so what happens is, by putting a number to the template file itself, so SK is for SketchUp, 21 is the version that we use, 01 is our first template. And so what happens is, as you're working, you might actually create more and more templates, so that you can actually customize it to how you're going to work. You might customize it for a particular project itself. And finally, one of the things that we need to think about is the model info. So by clicking onto the window tab, we can and it brings us down to the default for model information. So in model information, we can actually define the number of components, the file, the geolocations, the statistics, the text, and the units. So predominantly what happens is, let's look at units. So in this particular model that we're going to use, we're actually going to use metric, and we're going to use millimeters. So all the information that we type in millimeters throughout. And so consequently what happens is, by clicking onto the units, we can define exactly what we want to show. We also have the ability to change from the text. So instead of going for the default, we can actually go through. We can actually select our own. We can select our own fonts, and so we can customize the whole thing. So again, what happens is, if we go from units, go to text, click on the font, select what font you want, select the sizes. So you can actually set all that up specifically. So to review, we have a site. So the first thing we want to do is that when we start to actually, before we go into SketchUp, we need to think of how big our modules are going to be. We need to think about how they will interact regarding the site restraints itself. And again, what happens is, so you might want to use this little tiny grid to actually start developing your ideas. And finally, before we actually go onto the hands-on side, what we're going to do is that we're going to I've created you a series of links, so and that'll take you through the certain things like learning navigation, copying pillars, component bases, building platforms. So in plan view, what we're going to do, we're going to type out our base plan for our building. So you will see in the bottom left hand corner where we can type in the dimensions. So if you type in dimensions of 4,800, then a comma, then 9,600, it will create a rectangle. So let's have a look at this in plan view. So you can see there is our rectangle that we have used. Now what happens is that we can use the tape measure, which will actually create some hidden lines. So by clicking on the point and then dragging that point forward, what it will do, you can see this dotted line that appears on the screen itself. That enables us to actually to give us a starting point. So what happens is we can actually work more effectively. So once we've got defined our center point, let us go to, instead of using the rectangle tool, let's just use the line tool. Let's just click on the point itself, and if we type in a dimension of 2,400 millimeters, it will take us to our point, and then what happens is we can actually build up our space itself. So let's do this again. Let's type in 2,400, enter. Then along the red axis, let's type in our second dimension, which is 4,800. Then back along the green axis, we can type in 2004. You see we'll pick it up. Let's just extend this by a further 200 millimeters. And finally, what we can do is back on the red axis, it will bring us back to our model itself. So by moving from 2D to 3D, we can actually interrogate our model itself. If we decide to use the eraser button, what it will do, it will omit the links. And so what happens is, what we want to do is to actually create a complete polygon shape. So a polygon consists of all four elements. The other thing that we want to do systematically as we go through, we want to click on and to remove the delete the guidelines, and now we can go into the push pull, and we can actually pull up the slab by 200 millimeters. So you'll notice that in the slab that there are a couple of little lines appeared. So by scrolling in and using the eraser tool, we can actually delete those lines. So what it's doing is creating a complete clean space itself. Our next step, what we're going to do is that to create our walls by using the offset key. So by clicking on the edge and typing 200 millimeters, what it will do, it will actually enable us to define the thickness of our walls around our building itself. So what we're doing in SketchUp, we're actually building up a layer at a time. So we're coming from the base, we're then going to come upwards. So let's just define what the room size is going to be. So we want to create a bathroom, which is going to be 2,000 by 2,400. So again, go into the tape measure, click onto the corner itself, type in the value of 2,000. You can see what it does. We can actually create, it gives us our guideline. So let's just continue, and add a few more guidelines around our model itself. Then by coming down, we can actually let's come down 2.5 meters. Let's click another point. Let's use the tape measure to draw along and come down again. We can then define where the bedroom's going to be. So a bedroom wants to be 3,000 by 3,500, and so by coming down onto the axis itself, we can just come along, just type in the dimension of 3,000. It gives us a point, drag a line across. So consequently, what happens is we now have a series of guidelines. So bear in mind our model itself is 4,800 wide, then I've come off 200 millimeters either side. So by coming along 1200 millimeters, I can create a corridor. So consequently what happens is I have the set areas for my bedroom itself. So let's just use the line tool to define the rooms itself. So first of all, I've defined the bedroom, and then I'm going to just draw a single line to actually define the bathroom itself. So what this is doing, this is actually breaking our model up. So for clarity, let us just use the offset button. So if I come in 100 millimeters, I can define where the wall thickness is. So our internal walls are all going to be 100 millimeters. So type in 100, come along, and then save. Likewise, do the same at the top. And so consequently what happens is, so what SketchUp enables us to do, you can see that how the guidelines are actually defined. So we have the green, we have the green line. So if it stays in green, that means it's completely parallel to where it should be. If it changes color and goes to black, then you know you're actually not running parallel. So let's come along 100 millimeters. Let's draw a line back. And now we have our defined lines for the outer walls, and we can define the wall for our inner walls by selecting and drawing over. Let's just extend this wall a little bit further. Let's come back down, and consequently let's just complete the final bit of wall for the bathroom itself. So let's go to edit and then delete our guidelines so we know exactly what we've got. We can use the eraser to ensure that what we are creating are polygons. So if you don't have polygons, what happens is that it won't work. So let's use the paint bucket in order to actually define the areas. So we can see we've got materials, so we have various colors, we have textures within that. So what happens is, what the paint bucket does, it allows us to actually define and to change it, to actually customize it. We can bring in other materials from elsewhere. And so if we have the shape itself, we can actually apply the color to the space in question. So by using the paint bucket, you see that what it will do, it will actually form the space itself. So for the bedroom, I've literally just put a green paste in there for the time being. If I want to change the material, let's decide to go for a pattern fill. We have a series of pattern fills. So let me use a pattern fill. The shortcut is B for bucket. So and that will apply it to the space I have for the for there. So let's complete applying textures. What I'm going to do, I'm going to just change it now, and I'm going to apply a wood finish. I'm still in the bucket tool, so I'm going to apply that to the lounge area. Let me find something different for the for the remaining area. So you can just select whatever you want. As you can see from the library, there's actually quite a list of textures and materials within the program itself. So once we've actually finished applying our layers, let's now actually start using the pull tool and then extracting the outside walls upwards. So let's go to the pull tool. Let's select the walls. You can see that what I have is we have all the outside walls, and let's just type in a height of 2,800. So by using O and orbiting, we can now do the same for actually raising the internal walls, and we can do a similar kind of thing. So I'll raise the walls to the bedrooms. Let's come round. Let's find the bathroom. So don't be afraid to actually to use the wheel on your mouse to expand the view. Working in any 3D model programs, you really need a mouse to do this. So we have all our internal walls. So let's go and view our model a little bit more. Let's make sure that what we have fits. We can extend spaces. We can actually apply walls. We can cut openings into our walls. So this is what we're going to do next. So one of the things that we need to do, we need to actually start using the tags. Now, in this particular model, I've actually got quite a number of tags, probably too many. But basically, how do we create a tag? What is a tag? Tag is a layer. It's something that's unique. So by going into the default tray and going down to tags and clicking on the plus symbol, and so it will bring up the tag 1. Let us rename that, and let's call this base model. So if I left click on the screen itself and drag, what it will do, it will highlight my whole model. And let's just change that, and let's go along and select the one I've just created, which is base model. So everything I have within my model so far is all aligned to that layer. What the layers do, it actually enables us to select objects, and we can hide it, and so it gives us greater control behind how we're going to work. Likewise is that we can actually create a scene. What a scene does is take like a snapshot of our view itself. So by going into the plus symbol and click on scene, and what it will do is you will see that appears on the tab here, is we now have scene 2. So I can view my model. I can view it not only in plan view, I can also view it in elevation view itself. And so consequently what happens is this enables us to actually be a lot more proactive as to what we do. Again, I'm going to use the tape measure to find midpoints, so I can actually start setting out various elements. So if I want to create a hole in my front in the front wall of the building itself, so I can do this both in 2D or I can do it in 3D. So let me come along. Let me type in a value. And you can see that by coming 1,000 from each end, I can type in and actually put in a guideline that will formulate my opening, which I wish to create on the front elevation of the building itself. And so consequently, again, I can come 200 millimeters. I can come up again 2,400 millimeters. So what I've done, I've actually created. I've set up my guidelines for actually creating an opening. So rather than going into the elevation, or rather than just dragging and dropping, I can actually be more methodical as to how I work. So I can apply it in 3D, or I can apply it in 2D. So again, by drawing in a wall and then using the push tool, it actually enables me to push a hole out into my opening itself. So what happens is, if I'm going to create doors and window openings, what I want to do first is to define the size of the opening that I'm going to create. And then what I can do, I can then actually bring in an object. So on this model itself, I've actually created a little canopy on the front. So to do that, what is, again, I'm going to go to the offset button. I'm going to choose the layer. So let's call this new layer canopy. Let me go for the offset. Let me drag a rectangle shape on the front. And now what I can do is I can actually create an offset. If I click on the edge and come in the offset, and if I just type in the offset and type the offset to be 100 millimeters, what I can do now, I can now extrude it. I can pull it forward. Let me pull it forward to 1.5 meters, 1,500 millimeters. And what I'm going to do is I'm going to use the line tool to define exactly where it is. So what that's doing is actually splitting the walls itself. So what we need to ensure that we actually need to go all the way around the model itself. Otherwise, what happens is that we can actually end it with a distortion in the model itself. So not only would I do it on the sides, I would also do it at the top and the bottom. So let's define this by adding material. Again, what happens is, let's apply this material to all the faces. Let's rotate the model itself. And so consequently what I can do is I can then create this object. So there's the line at the bottom, and now finish it off by applying the material. And I can use the pull push tool in order to actually make it a little bit bigger than the module itself. Bear in mind that what we've done is that we've only got 200 millimeter walls for this component. So what happens is, in reality, this module would actually be made in a factory, probably in two components, put together and brought to site. When it's on site, the additional elements can be added to it. So, for example, is that a 200mm wall will not give sufficient thermal capacity for a dwelling. It needs to be at least a minimum of 300, ideally 350. And so what happens is, in reality, is that way that we model up is that we bring the component to site, and then we will apply the external cladding around the building itself in order to actually give it a higher level of thermal warmth. So again, by using the key, by scrolling from left to right, you can see I've highlighted everything here in blue. I can actually now make that as a group. I can delete the elements I don't want to have in, and what happens, I can actually make that as a component. But we'll go into making components in more depth in the next webinar. And so the principle behind this module is to literally just take you through the basics. And so what we've done so far, we've used the pen tool, we've used the tape measure tool, we have created layers, we have used the eraser. Again, in the next webinar, we'll talk a little bit more regarding the use of actually bringing objects in. And so predominantly what happens is that if I've got an opening and I want to bring objects in to the model itself, we will use the Trimble warehouse. And within the Trimble warehouse itself, it actually allows us to bring in objects such as trees, doors, furniture, so that we can actually populate it. So by going in the 3D warehouse itself, typing in, so let's just type in sliding doors. We can select a door from the library itself. It opens up the library, and then what happens is, by scrolling through, these are objects which are already in the library itself. We can add elements, we can upload them into the library. And so what happens is we can select it, we can download it, and then what we can do, we can then actually apply it to the model itself. Another option that we can do is that we can actually create our own doors and windows within the object itself by simply putting in a rectangle, extruding that rectangle, and then from there we can actually create our own doors and windows. We can use it to actually cut an opening. And so literally by using the push command, we can simply push an opening into our walls. So when we bring in doors and windows into our model itself, we have a predefined opening that we can actually extend within our model itself. So what we have, we have a model itself. We can go into, we can start editing the model. So if I wanted to, for example, is to extend this wall itself, I can use the line tool, and I can use the push command, and you'll see what it will do. I get this command, it tells me that it's actually offset 1200 millimeters. So it's offsetting into the external wall. Let's just do it again. So I'll use the pencil just to extend the wall itself. So I need to drag a line along the top, and I'll also need to bring a line down from, so you can see that the line itself should be in blue. There we go. And then I can go to the extrude command and actually pull the extrude command from that point itself. And so what happens is that, you know, I can define my openings. I can come along, I can use the line tool. I can set the line tool from a defined point. I can use the tape measure. And so what I'm looking for here is that, you see that the wall there, the line is going to be in blue. So if I wanted to create an opening, it simply is to use the pencil. So it needn't necessarily be rectangular. I can define the height of where the opening is going to be. So let's come in at 2.1 meters. Let me just draw a line across. So you see I have a red line. Let me use the eraser to delete the section of line I don't want. Let me delete my guidelines. I can highlight it, and again I can push onto the face cell to actually create an opening. So it's a quick way of working. We're not going to do it in this particular model. Start putting external windows into the model itself. That's something again we will touch on in more detail when we're actually working in webinar through the next webinar. Okay, right, to complete the model itself and this webinar, we're going to add a roof to our building itself. So by rotating our model around, let us just select an area which intersects with the canopy which we put on the front of the building itself. I'm going to take a rectangle and I'm going to left click on the corner and I'm going to drag it to the far end. So what I've got is, you can see here, enables me that what it's enabled me now is to actually pull and push this section of roof itself. So just pull along a little bit, then go in to actually use the line tool, and let's just define the edge itself. So I need to actually define the top section, and I need to define the two bottom sections, one on the left and one on the right. So let's just change the material for what's going to form our roof. So I'm going to go back into my paint bucket, into my materials, and I'm going to apply a grey to the roof itself. I'm going to apply it to the edges. So make sure that I'm rotating around. Let me just select and finish off the final edge. And what I can do now, I'm going to extrude the height a little bit, take it up from its existing thickness. So we can define what this is going to be. So let me just add this by 200 millimeters. I can then drag and extrude it. So by pulling it right to the very edge, you'll see what happens is it'll tell me its offset limit. So just stop there for a moment, drag it again and pull it again. So this time it's taken to the offset limit of the entire building. And then let's just pull it just a little bit further away. Let's pull it. Let's extend it by another 100 millimeters beyond the end. And now what we're going to do, in order to actually maintain this polygon, I'm going to take a line tool. I'm going to draw it offset from the intersection itself with the outside wall of my model. Again, what I can do is I can use the tape tool to define where that's going to be, and then I can use the line tool to define the edge, and then I can go to the pull command and pull it to extract. And so what happens is, once I've got this basic flat roof, I can then again, you notice that what I'm doing is I've started working upwards throughout on the model itself. I can then use the offset to define part of the roof itself. But first of all, before I do that, is let me select the whole roof itself. Let me apply it to the roof layer itself. So if I wanted to hide the roof, I can do so. And now I can use the line tool to draw a line across on the edge. Let me go to the offset button. Let me come in offset. Let me put an offset in of 500 millimeters. Let me extract by using the pull command. Let me pull that up by 150 millimeters. And then what I can do is I can do another offset, this time for 150 millimeters, and then I can use the push-pull command just to push the section of roof down just a wee bit, say about 50 millimeters, to define it. And so consequently is that I can use that as a base. Let me just turn that section of roof onto the building to be a green roof. And so what we now have our completed model. You can see that by simply working through and being quite specific regarding your dimensions. So what we need to think about is that we can't use SketchUp for actually for actually developing our ideas. We've really got to develop our ideas on pencil beforehand. So by doing little sketches, thinking it through. So having a parameter and understanding exactly how it's going to work enables us then to actually to developing our idea. So I hope you've actually enjoyed this webinar. Just to let you know that the next webinar is scheduled for the 26th of January at 4 p.m. That webinar we're looking at sketch development of the concept model. That's going to be presented by Meta, and the agenda will go through. There'll be a little 10-minute review regarding SketchUp in a nutshell, and that will be by a 40-minute development of the concept model, and within that we'll look at creating components and important objects. And that will be completed by a 10-minute Q&A. Should you have any questions or queries, I've included the emails and the contact names for Natalie and Meta. And hopefully I hope you've actually enjoyed this webinar, and look forward to seeing you all on the 26th. Thank you all very much.